Hello my dear students, welcome back to Learn Physics. In today's topic, we are going to discuss about ray optics portion. In that, optical instruments. So, first optical instrument which we are learning today is simple microscope. Simple microscope, we know it is used for observing the magnified images of tiny objects. If very small objects are there, we can see it as little bit bigger with the help of simple microscope, right? So here this is the ray diagram for the simple microscope. So if we are keeping the object over here, then by viewing it through the simple microscope, we can see it as much bigger than the original one. So in the case of simple microscope, we will be using only one lens. Object will be placed within the focus, between principal focus and the optic center. Between these 2 points, we will be keeping the object. Okay, and the image will be forming at the least distance of distinct vision. Okay, that is magnifying. So how we can find out what are the important points for the simple microscope which you need to remember. First one, when image formed by a simple microscope is at infinity, the object must be at focus. If the image is forming at infinity, the object will be placed at the focus. And what is the formula for magnification? M equals capital D by F. What is capital D over here? That is the distance which we learned here now is the image where it is forming divided by F. Okay, infinity. Okay, object is at the principal focus, so capital D by F. D is the image which is formed at least distance of distinct vision. Then single lens suffers from defects of spherical aberration and chromatic aberration. So since it is of single lens, it will be having spherical aberration and chromatic aberration. These are the defects of simple microscope. Next we are going to study about the compound microscope. Compound microscope means it will be little bit more good image, or magnification will be little bit more for compound microscope. Here we will be using 2 lenses because we are getting very highly magnified image for tiny objects, right? So we are using 2 lenses. Both are convex lenses only. So the lens which is coming near to object will be objective lens, and which is near to the eye will be eye lens. And it will be the aperture of the objective will be little bit bigger than the eye lens. Clear? So this is about the compound microscope. So here object is kept over here AB, and we will be getting the image, initial image at FE. So between the optic center and principal focus of the eye lens. Okay, we will be also getting the image over here. If it is between F and O, image will be formed at infinity. It is actually it will be a virtual image that time. An enlarged image we will be getting. Right? So this is about the compound microscope. Next we are going to find out what will be these formulas you should by heart. Okay, what will be the magnifying power of a compound microscope. Here you can see this is object where we kept the object, and image is forming at the principal focus of the objective lens. So image is forming at the principal focus of the objective lens. So here we kept the object just after the principal focus of eyepiece. We are getting an image. The position will be adjusted in such a manner. We will be getting the image at the principal focus of the objective lens. Clear? So while we are adding this VO and this FO, Okay, we will be getting the value of the length of the tube, microscope tube, length of the tube we will be getting like that. Next, if the final image is formed at the least distance of distinct vision, what will be the formula for magnification? So magnification, for if we are using two lenses, combination of lenses, how the magnification will be? Multiplying the magnifying power, or magnification, when we are multiplying we will be getting the total magnifying power of a combined lens. Here, since we have two lenses, E is there, magnification of eyepiece, and magnification of objective is there, right? So this is objective and this is the eyepiece. Okay, here it is, you please read this as eyepiece and this as objective. Okay, so when final image is formed at the least distance of distinct vision, the formula will be V by UO, VO divided by UO into 1 plus D by FE. Okay, this is the formula to find out the magnification. So usually we will be taking only the magnitude, no need to take the negative sign. So VO divided by UO into 1 plus D by FE. So if the final image is forming at infinity, okay, if the final image is forming at infinity, then magnification will be VO by UO into D by FE. Clear? VO by UO into D by FE. Usually VO by UO, here it is forming, final image is forming at infinity. So VO plus UO, what is that? It will be the length of the tube. So we can write it as L by, what is UO here? It is FO, right? So that is, here we will be getting L by FO into D by FE. That formula also you can use. This is the case of normal adjustment. If you are saying normal adjustment, you can write the formula as VO by UO into D by FE, or L by FO into D by FE also you can use. So all these formulas you should be thorough, and the diagrams also. Okay. So the next one, astronomical telescope. In astronomical telescope, what is the use of this astronomical telescope? We can observe the large distance. If the object is at very large distance from us, we can observe the object very clearly. That is, distinctly we can observe the objects, especially the heavenly objects and all. We can observe it through with the help of astronomical telescope. So in normal adjustment of this astronomical telescope, the final image is forming at infinity only. So here you can see the objective lens will be little bit bigger than the eyepiece, just opposite to that of the microscope. Here also we are using two lenses, one is objective and the other is eyepiece. The lens which is coming closer to our eye, that is eyepiece. The lens which is facing towards the object is called a objective. Okay, so here magnifying power M equals FO by FE. That is the formula. M equals FO by FE. So in normal adjustment of the telescope, distance between the objective lens and eye lens will be FO plus FE. Okay, in normal adjustment, FO plus FE will be the distance between the object and eyepiece. Okay, angular magnification also we can find out, beta by alpha. Object distance, object angle divided by image angle. Okay, beta by alpha, that is angular magnification. That also, see these formulas and all should keep that in mind. Then only this, while doing the this one word questions and all, you can easily find out. See here, magnifying power, FO by FE. I told you just now, I told you about the magnifying power, and if the image is forming at this normal adjustment, the distance between the objective lens and eye lens will be FO plus FE. So if the question comes like, if in normal adjustment, in that word is there, means you should understand that the distance between the object and eyepiece will be FO plus FE. Okay, clear? Then at the least distance of distinct vision, that is final image is forming at least distance of distinct vision, which is 25 centimeter for the normal eye, right? So magnification will be, magnifying power will be FO by FE into 1 plus FE by D. Okay, so in normal setting of telescope, the final image will be at infinity. That time magnifying power will be minimum. Okay, clear? So minimum magnifying power for FO by FE, and magnifying power will be maximum for this at least distance of distinct vision. We will be getting the maximum magnifying power. Reflector. Here, what is the radius of the curvature of the reflector? That is divided by 2, the whole divided by focal length of the eyepiece. Okay. Then, what are the important points for this Cassegrainian telescope? In normal settings of the telescope, the final image is at infinity and magnifying power is minimum. That is about the telescope. In the case of telescope, final image, normally it will be forming at infinity only. At that time it will be minimum magnifying power, but it will be maximum when it is at the least distance of distinct vision. To get a good quality telescope, we should use the telescope which is having large magnifying power, large resolving power, large light gathering power. All these are the good qualities of a telescope. Okay, the magnifying power of a Cassegrainian telescope is R by 2, the whole divided by Fe. So these are the important formulas and points for this optical instruments. So I hope it is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.